Hey, this is Mr. Ward, and this is a video key for the exit ticket 21.1 for geometry. And we're continuing to introduce and explore a few concepts from 5.5 and 5.6. So you will need to review, look through these properties of parallelograms and rhombuses for the next question. So, and the reason I included parallelograms is mainly because parallelograms, rhombuses are special cases of parallelograms. So they have all the same properties of parallelograms plus a few extras. So you'll want to read through these. Opposite sides are parallel in a parallelogram. Opposite sides are congruent. The opposite angles are congruent. That's really important today. With this one, diagonals bisect each other, and any pair of consecutive angles are supplementary. And then for rhombuses, all the properties of parallelogram apply by definition, and all sides are congruent. And rhombus is an equilateral. It's like a squished square. The sides are all the same, just the angles are not necessarily right angles. Okay. The diagonals bisect the angles of the polygon. That means this diagonal splits JOM into two congruent angles, and JM bisects OJK and also OMK. Those are bisected by that. And the diagonals are perpendicular bisectors of each other. So we're going to use that information to determine the angle measures and also whether the short diagonal would produce an equilateral triangles. So let's look at this. So it's important to remember that the total angles inside a quadrilateral are 360 degrees. So let's draw. I'll go with blue. Okay, so I'm going to draw a rhombus. And like that. And here's things we know. We know the ratio of the measures of the two angles of the rhombus are 2 to 1. Now, any two angles consecutive according to since it's a special case of a parallelogram, these two angles are going to be supplementary, which means they add up to 180. So now we're not dealing with the opposite angles because the opposite angles will be the same. So it's not going to be a 2 to 1 relationship. So we've got to only be dealing with consecutive angles. So this angle and this angle add up to 180 degrees and have a ratio of 2 to 1. So we know then that 2x plus x equals 180. So we just got to figure out what x is. Okay, well, that's 3x equals 180. So x has to be 60 degrees. Okay. So this is the narrow one. That's the more broad one. So one of them is 2x. So 2x is 120 twice 60. So then this angle is 120, and this one is 60. 120, I'll write it out here because it'll be a little easier, and 60. Okay, now, here's where some of the properties of a rhombus come into play. So we're going to be drawing diagonals, okay? We need we're going to draw these. So we've just figured out the measure of the angles, 60 and 120, 60 and 120. Now, if the short diagonal is drawn, and that would be across the narrow angle like that. So I don't need that anymore because we know both of them are 120. So I'm going to draw that short diagonal. Now, if we go back to our rhombus properties, something we're going to notice is that the diagonals bisect the angles of the polygon. So that means that this angle is this diagonal, is bisecting this 120-degree angle. And if it's bisecting it, then that angle right there is 60. That's 60. That's 60. And that's 60. And if you recall back in types of triangles, there's a thing called an equiangular triangle, which is the same as also an equilateral triangle. Equiangular triangles and equilateral triangles are the same dang thing. So now we have demonstrated that the angles are 120 and 60 degrees, and the short diagonal produces two equilateral triangles. Okay, I hope that helped with that one. Let's take a look at the next one. So one of the ways to prove a quadrilateral is a parallelogram. One of these ways to prove, sorry about the wording of this. One of these ways to prove a parallelogram is a quadrilateral. I'm going to start over. One of these ways to prove a quadrilateral is a parallelogram tools. That's worded badly. What I'm trying to get at is one of these tools for proving a quadrilateral is a parallelogram is key to the proof in the next question. I will fix that before y'all are working with it. So we've got these tools. If both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. If both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. If two sides of the quadrilateral are both parallel and congruent, then it's a parallelogram. If the diagonals bisect each other, then the quadrilateral is a parallelogram. And if both pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram. So let's consider the situation we got here. We got this pretty funky looking quadrilateral, JKOP. What we're trying to prove is that JMOP is a parallelogram. It looks like one, but we can't assume that from the diagram. So here's things we know. We know KR is a median. KR is a median to JO. Okay, and that tells us something. That tells us JO has been bisected. That's what definition of a median. So let's start with KR is median to JO given. And then we can say that JR is congruent, AR is congruent to OR by definition of a median. Okay, so let's label that information. Flump and flump. We know that. Don't like how I drew that one. I'm going to get rid of it, and I'm going to redo it. Okay, so there we go. So JR and OR are congruent. Neat. So now we know that RP is congruent to Km. So RP, here's what we're going to say. RP is congruent to Km. That's a given. Okay, so RP is congruent to Km, given. Okay, and then we're also told that Rm is congruent to Km. That's also given. Now, by transitive property, we can also say that Rm is congruent to Rp because Rp was congruent to Km, which was congruent to that, and so therefore Mr and Rp are congruent. So now we can say Rm is congruent to Rp Bitransitive property. Okay, now we have, now I think we have enough to say that JMOP is, or we just about have enough to say that JMOP is a parallelogram. We have one more thing to say. Now we can say, so we knew that JO was bisected. Now we can say that JO bisects MP because RM and RP are congruent. So let me scroll down a little bit. So we can say that JO bisects MP because MR and RP are congruent. And now that we know that, let's go and see if we have enough information. Okay, if the diagonals of the quadrilateral bisect each other, and that is definitely happening, JO is bisecting MP, and MP as part of KR, related to KR, that is also bisecting JO. So the diagonals do bisect each other, so we can now say JMOP is a parallelogram because the diagonals bisect each other. And that is all you need.